Okay, so this is the same example that we were just doing, but we're going to do this with the shell method as opposed to the disk washer method that we just did. So from the previous video, we know that my points of intersection here are at the point 1, 1 and over here at the point 0, 0. Those are our points of intersection. So if we're going to do this with the shell method this time, as opposed to the disk washer method, then now the rectangles that I draw in my region up there need to be parallel to my axis of revolution. So when I draw my rectangle here to be parallel to my axis of revolution doing the shell method, then I now notice that I'm going to have a horizontal rectangle. So I need everything that I have up there to now be in terms of y. So I need to take both of my equations that I have, y equal to x squared and y equal to the square root of x. I need to solve both of those in terms of x. Solve for x so that I get everything in terms of y. I said that backwards. So if I take y equal to x squared and solve this for x so that I have everything in terms of y, I get that x is equal to plus or minus the square root of y. For my region that I have there, which is in the first quadrant, I just need the positive square root, so I'm just going to worry about x being equal to the positive square root of y. For my other one there, where I have y equal to the square root of x, if I take that one, then I get that x is equal to y squared if I square both sides. Alright, so again, remember that when I originally graphed this, I had in red there, that was y equal to x squared, and in blue there was y equal to the square root of x. So now, if I label the endpoints that I have there for my rectangle, then this is y squared, comma, some y value, and then over here, this point here, is the square root of y, comma, some y value. So I need two pieces to use the shell method. I need the length of my rectangle, or if you want to think of it, the height, even though it's turned sideways. So I need the height, the length of that rectangle. So from my picture there, I have that h of y. Do it in black here. H of y is going to be the square root of y minus y squared. That is the length of that rectangle there. Alright, now, the other piece that I need is I need the distance, so I need p of y. I need the distance that my rectangle is that I drew there. I need the distance that it is from my axis of revolution. Now, for this rectangle here, this is just some x comma y value. What that represents, just some x comma y value. And then here, up here and there, this is just some x comma and my y value is 4. So my y value doesn't change. So any point inside that rectangle would represent the distance that I am from that axis of revolution, and that is just some x comma y value. I have no idea what the x value, no idea what the y value is, just represented by some x comma y. And then up there on that line y equal to 4, my x value could be anything and my y value never changes. My y value stays a constant of 4. So the distance that that rectangle is from my line of revolution is represented by 4 minus y in this case. And I cannot stress to you enough, either method you're using, whether you're using disk washer method or the shell method, being able to label the endpoints of those rectangles will help you get h of y or h of x, depending on which way your rectangles are turned. And once you have those, you can label the inside of that rectangle by just some x comma y, and then label your axis of revolution as well, which in this case is y equal to 4, and that will give you your distance there from the axis of revolution, which is represented by 4 minus y. So that's with all these methods, being able to do that, to me, is the key in helping you set these up. Alright, so now that I have everything that I need, now I'm integrating with respect to y, but in this case, I'm going to go from 0 to 1, just like I did a minute ago with respect to x. It just happens to work out in this case. But keep that in mind that we are integrating here with respect to y, so we need everything in terms of y. So my volume is going to be 2 pi, since I'm using the shell method. My volume is going to be 2 pi times the integral. My bounds, in this case, still go from 0 to 1, just because of the nature of the region that I have there. Excuse me. And then I have h of y, which is the square root of y minus y squared. And I have p of y, which is 4 minus y. Now, what we got a while ago for the answer was 71 pi over 30. So we want to get the same answer in this case. So my volume, so I'm going to work this out, is going to be 2 pi times the integral from 0 to 1. If I multiply this out, I'm going to get 4 times the square root of y, or 4y to the 1/2, minus 4y squared, and then minus y to the 3/2. If I multiply the square root of y times y, I get y to the 3/2, and then plus y to the 3rd. Those are my 4 terms that I get when I multiply those two binomials together. I get 4 times y to the 1/2, and then 4 times negative y squared is negative 4y squared, and so on. So I get my 4 terms there. So now I just need to integrate each one of those pieces. So this is going to be 2 pi times, integrate y to the 1/2, and you get 2/3 y to the 3/2. You have a 4 there, so that's going to be 8/3 y to the 3/2. Minus, integrate y squared, and you get 1/3 y to the 3rd. You got a 4 there, so that's going to become 4/3 y to the 3rd. Minus, integrate y to the 3/2. That's going to be 2/5 y to the 5/2. And integrate y to the 3rd, and that's going to be 1/4 y to the 4th. All that evaluated from 0 to 1. Now, just like a minute ago, my lower bound is going to be 0, so I'm going to plug in 0 everywhere. That's all going to disappear, which is nice in this case. And my upper bound is 1, so if I plug in 1, all those powers of y are going to end up just being 1. So what I'm going to have is just 8/3 minus 4/3 minus 2/5, and then plus 1/4. Alright, so now I need a common denominator. So my volume is going to be 2 pi times, get your common denominator here. So 5, 4, and 3, that's going to be 60. So I'm going to use 60 here. So I multiply by 20, that's going to give me 20 times 8 is going to give me 160. 20 times 4 is going to give me 80. And then 2 times 14 is going to give me 28. And then 4 times, sorry, I did that wrong. I can't multiply. Sorry about that. Do 5 times 12. 5 times 12 would give me 60. So 12 times 2 would give me 24. And then 15 times 4 would give me 60. So that would be 1 times 15, which gives me 15. Alright, so my volume is going to be 2 pi times, let me just double check myself, so 20 times 8 gives me 160, 20 times 4 gives me 80, and then 2 times 12 gives me 24, and then 1 times 15 gives me 15. Just double checking myself there. Alright, so I have 60 for my denominator. So 160 minus 80 is going to give me 80. 80 and 15 is going to be 95, and then 95 minus 24 is going to give me 71, luckily. Okay, and then I have the 2 out there, so the 2 and the 60 will reduce, 2 to 1, 60 to 30, and so luckily, if I multiplied correctly, I get my volume is equal to 71 pi over 30. Same answer we got using the disc washer method a while ago. But again, this part's just the integration. Just be careful with your multiplying. Okay, that's not the hard part. The hard part with these problems is getting that region drawn and making sure you get everything set up like you should. But again, make sure that you label the endpoints of those rectangles and label points in there that you need to help you set it up, whether you're doing it with the disc washer method or here with the shell method. And I think that will help you tremendously take all the guesswork out of what you're trying to do here. And just keeping in mind when you should draw your rectangles parallel with the shell method and when you should draw them perpendicular like you do with the disc and washer method. So hopefully these 2 examples that I've done for you will help you with your homework and help you with just to refer back to if you have some extra questions that I can't answer for you.